the last part of today's lectures, we're going to talk about just how groundwater flows and moves, and we'll go more in depth into this later on. So as we were talking about watersheds, that's surface water flow, it does include part of that groundwater surface water interaction that I've talked about. And groundwater moves from higher head to lower head. So we call these hydraulic heads. So groundwater will move from higher elevation to lower elevation, but if you're inside of a confined aquifer, you might not be flowing, you can actually flow up, flow downhill, flow uphill, because you can have water being pushed uphill from that, and we'll get into that in just a second when we talk about artesian. But what we do is we usually talk about water having what we call hydraulic head, and that is the pressure and the elevation pushed together to make hydraulic head. So water will flow from higher head to lower head, and this is across a gradient in here. And so groundwater will flow across these things. So groundwater flow can be different systems. So as I said, with watersheds, the watershed is generally the surface area, but we can have these watersheds where we'll have these groundwater flow divides that happen very deep, and this groundwater will flow into different areas based upon that. And here's our water table. And so we'll have these equipotential lines, which it means an equal potential, and so water will flow from higher head to lower head, and we'll get water flowing into these deeper areas. And so when we look at regional flow, we may have these regional watersheds or flow areas, but we can have this longer or really flow systems that go deep and go into different areas. And so when we talk about watersheds, we can have watersheds within inside of watersheds. So we can have a basin, and we can have all these little watersheds within inside of the bigger watershed or a bigger basin. We can have groundwater flow that crosses between different watersheds. And so by understanding all of these different complex issues of water and where water is flowing, we can then better understand where we get our water from and where logically we should be getting our water from, and what the impacts will be if we start over pumping or over withdrawing water levels. Because as this water flows to these local systems, if we draw down, I'll say, a river here, and we draw that down, that's going to change all the groundwater flow too, because remember, groundwater and surface water flows are connected to each other. So we can change the whole dynamics of flow in our system, and then when we do that, we may be changing how much water a system is getting, water quality. We could be changing a lot of different things within inside of our system. The last thing I want to talk about today is our artesian wells. So we've all seen these. There's water out there that says it's artesian well water. And artesian well water is perfect. And so you can buy artesian well water bottles. Okay, well, what does artesian water mean? There's a very strict definition of it when we talk about hydrogeology that I'd like to go into, and let's talk about water quality associated with it, because the marketing people have said, oh, wait a second here, artesian water, that's the best water is. It's artesian spring water. It means that it is fresh from the ground. I just saw some ads for some, it's glacier water, it's spring water, it's pure and clean and all that. Well, let's look at what this actually means to see, is it really actually clean? Is it better? What is it? So an artesian well, you are drilling into a confined aquifer. So, we talked about confined aquifers. They're squished from the top and the bottom, and you're squishing the water inside of there. So you have a confining layer on the top and on the bottom. Well, what do we say about confined aquifers? Generally better water quality, just because we have that layer of clay or some sort of material that slows the water down until it gets into there. But it's under pressure. Contaminants still can get into it. I talked about drilling wells improperly. What happens if we had a well that isn't grouted all the way through that? We can get contamination flowing between two different aquifers. So that can happen. So what this is the pressure is high enough to push the water out of the well. So we're squeezing that water out between these two confining layers. These two confining layers, there's so much pressure on it that the water just shoots out the straw. So if I had an example here and I had these two pressure points and I put so much pressure on it, the water just squirts out naturally without having to put a well into it. That's what artesian means. So an artesian well is just enough pressure that's being pushed into it that water comes out without putting a pump into it. And that's the same thing with spring water. Spring water just means that it's a discharge point of the water from the ground. It doesn't mean, and when it's spring water, that it's under pressure or anything. It's just a discharge point. We have discharge points inside of our rivers and our streams everywhere. We have discharge points everywhere. It can be from a shallow system. So when we showed some of these, you could have this little local system right here where this is the discharge point for this, and that's spring water. It just means that it's the groundwater is discharging without pumping. So you could have a pollution source here and it could be dumping it right into there. And it has nothing to really to do with water quality. It's totally to do with water coming out of a well without pumping. So what people will do is generally say this is cleaner water because this water is coming out from the ground without a pump or anything. It's generally cleaner. Well, that in some parts is true because the soil acts as a filter. So one of the benefits that we have here in, say, in Illinois is that we have all this soil here that acts as a giant filter that cleans up the water as it moves through that groundwater system. Now, we will talk more about this with groundwater, but as the water is moving through the ground, it's picking up the minerals that are in it. So this is why our water tastes very different here in DeKalb than it does in, say, Chicago, is because that groundwater is flowing, that water is flowing through the ground. It's picking up that calcium carbonate, that calcium, that magnesium from the soils, and then that's coming out. And so this is why our water tastes different. So while it may not have pollution, we're filtering that water, it's still picking up some of the minerals that are inside of there. So artesian water doesn't, it's going to be just the water that's in there. So I'm going to focus in a little bit more. I'm going to go 200%. I want to kind of talk about this picture over here. Let's see. I'll focus on it a little bit right here. Okay, so in this case here, we have a mountain range next to farm fields. So this would be kind of analogous to what's going on in Colorado area, but we can say wherever the recharge point is. So for our aquifer here, for the aquifer that when I showed you the maps of where a lot of our groundwater comes from, the recharge point for the St. Peter sandstone, which feeds a lot of the suburbs that you saw in those maps which showed using groundwater, the recharge point for that is out in Oregon, Illinois. So you go out to Oregon, Illinois, you'll find some of the St. Peter sandstone outcropping there or coming out of the ground. Well, that's analogous to this area over here. Okay, so it's slightly higher elevation. This is where the St. Peter sandstone comes out, and this is where the water recharges into the system, just to give you an example of what this recharge is. So water, groundwater, whatever flows into this area, and then it flows through this confined aquifer. So we have the aquitard on the top and the bottom. We have this aquifer here, and we put a well in. And well, because this is so much under pressure, the water just comes out naturally. So you can see here, here's the water surface. This is the potentiometric surface. We call it potentiometric because it refers to how much potential it's dealing with pressure. It's a combination between pressure and elevation. And so we'll get this water level here, and that kind of goes across the system. And so if this well was higher, like up the well casing, or we talked about well casings, if that well casing was right here, it wouldn't be flowing out. But because the well casing was here, the water will just flow naturally out because it's under so much pressure. But say we put a manufacturing plant right here, right at this recharge point, and we put in a chemical factory. Well, that chemical factory, that water then goes through that system and will actually contaminate it. So we have to understand where our water comes from and where it's recharging back into the ground. We talked about budgets, where it's recharging back into the ground so that we can then protect those areas, because that'll protect our water down gradient from it. So here's our gradient, here's our water up here. So does artesian water mean that the water quality is great? It has nothing to do with water quality. It just means that the water comes out of it without pumping. So when we talk about water bottles and we talk about all that kind of stuff, are we actually talking about water that's good quality when it says artesian? No. When it says spring water, what does that mean? It just means the water discharges out from the ground. And as you're seeing, as groundwater flows, we can have a discharge point everywhere, and it has nothing to do with the water quality. Water quality is based upon a lot of other issues. from anthropogenic sources, the types of soils. We'll get into a lot more stuff about water quality coming up and some of the important issues associated with that. But I just wanted to point this out, that so when you do have a water bottle that says artesian spring water, yeah, so. Oh yeah, and one other thing, I just want to bring this up because I hate Fiji water. Okay, the Fiji water, it says pure from the source and everything like that. 25% of the population of Fiji does not have access to clean drinking water, yet you can go to a store around here and pick it up. So, and there's nothing pure about it. It says untouched by man, and that's the commercial for it. Oh, I'm going to show you that commercial, and we're going to just make me upset this afternoon. So hold on one second. Okay, so here's the Fiji water commercial problem. Oh, wait a second, hold on. I can't remember if I have it so that you guys can actually hear the commercial, but you guys would probably have seen this water where it says, Fiji water is a gift from nature to us to repay our gift for leaving it completely alone. Bottled at the source, untouched by man. It's Earth's finest water. That's what it says. So I'll have to check to see if you guys can actually hear it. Hold on a second. So that was the Fiji water commercial. I'm going to look at some of these other videos about Fiji water, but first of all, touched by man. Touched by humans. But it is not touched, but so is not our water. I mean, the city of DeKalb's water hasn't been touched by man because it's been inside of the ground since the last glaciation, which was, 10,000 years ago. So the waters are thousands of years old. So this is very misleading. It makes you think that this is pure water, that it's bottled at the source. Well, all water is bottled at the source. I mean, what are you going to do? You're going to run a pipe for, 12 miles before No, you bottle things at the source. It's not touched by man. A lot of water is older than humanity's been around. The reason people like Fiji water is marketing. I do like their square bottles because they do sit easier in there. But think about the carbon footprint of the plastic water bottle that goes into it and being charged all the way from Fiji. I mean, the water actually comes from Fiji. And the reason people like it is that it's slightly alkaline water. It makes your stomach feel slightly better, but it has nothing to do with water quality. It is you can get so okay. I might put up some other videos about where does Fiji water actually come from, but drives me nuts. Okay, so that's the end of my rant for today. I hope you enjoyed it. I will be seeing you later.